Obviously, the other thing that is present in the gut is the flora. And the flora is also, we came to the realization that the intestinal microbiota is so unique to each one of us. It's like our personality. There are basically no two individuals with the same microbiota identically. The major components are the same, but when you look at the individual composition, it's very unique. These, for instance, are two twins, and you can see they are very different. And you can see that just because the baby had the formula and the other was breastfed, the composition of the flora is completely different. Again, early impact on a major component of gut physiology, the flora, and consequences probably for how the immune system will recognize the flora and the potential for developing diseases. And this obviously has led to what's called the hygiene hypothesis, in which being exposed to an artificially clean environment of modern society is supposed to be bad. This is hard to prove experimentally, but this is a very nice study done in Scotland, where Dr. Kelly, who's a mucosal immunologist, took 54 pigs and divided them in dirty pigs and clean pigs. And the dirty pigs were basically left out there, whatever. They ate whatever they wanted and they do whatever they wanted. And the other 27 were kept inside with restricted diet and antibiotics. And when they looked what happens in the gut, they realized that not only the composition of the flora was different, but while the dirty pigs had a balanced immune distribution, particularly in regard to pro-inflammatory genes, the gene expression in the clean pig had all increased gene expression for inflammatory genes, and also, interestingly, for cholesterol synthesis, which are the hallmark of a modern human. So I guess we probably have to go back to caves to avoid IBD or something like that. Another proof of the importance of early events in life in IBD is this great study that can only be done in countries like Denmark or Finland, where they had these mega registries of everybody that was born for the last 50 years, and they know exactly what happened to you from the birth to death. So what they did in this study, they followed up 500,000 children born during a particular period of time, and they asked the question, how many develop IBD? And they asked the question, how many took antibiotics early in life? And if you look at the findings, it's clear that taking antibiotic early in life increases the risk of IBD, and particularly Crohn's disease, by 3.3 factor. Probably we modulate the flora, and with that we modulate the intestinal immune system. So again, early event having a determining impact on the outcome of diseases. And this is probably true for many other chronic autoimmune diseases. We now start to understand that the bugs in the gut not only help to metabolize food and absorb nutrients, but they also, the composition of different bugs in the gut determines the composition of the immune system. This is from an editorial from Fiona Parry, and for instance, Sarkis Masmani a few years ago showed that Bacteroides fragilis produce a molecule called PSA, polysaccharide A, which condition the appearance of T regulatory cells. Now we know that Faecalibacterium prausnitzkii is a protective bacteria. The Clostridium species develop other type of TGA-beta producing immunosuppressive cells. So clearly there is a relationship between the composition of the flora and the type of immunocytes that we develop in the gut. And with that, obviously, shifts in the flora induced by antibiotics or by food can very well alter the composition of the immune system in the flora and make it more pro-inflammatory or anti-inflammatory. And the other concept which I think is becoming established, not only in IBD but in general, is that our whole life and our health or lack of health really depends much more than we realized before from the gut flora. The gut flora is much bigger than we are, both in numbers and gene expression. They are 100 times bigger than us. And obviously, we need to get along with the flora if we want to be healthy. And if we do something to the flora by altering with inappropriate feeding or antibiotics, we may get in trouble. And we know that certain foods alter the flora, and we tend to blame the flora for being overweight, when in reality, we should blame ourselves. But it's now well established that there are microbes, probably conditioned by the eating, that caused the superorganism, us humans, to be fat. And fat is not good, because fat is a state of low-grade inflammation. And if you have that throughout all our life, you can imagine that some organs will be affected. When I was growing up and I went to medical school, I was told that having a little bit of fat in the liver is not a big deal. You don't get disease, it's just there. Now we have all these epidemics of NAFL and NASH and so on, and the fat somehow leads to inflammation, scarring and necrosis and apoptosis and so on. So this is probably is a reflection of in one organ, or what can happen in many other organs in which the dysregulation of metabolic and homeostatic pathway lead to low-grade inflammation that leads to organ dysfunction. And this probably is also true in inflammatory bowel disease. What is interesting at this event, again, are not something that are easily recognizable, and particularly we don't know when this process starts. This is a paper that will come out in IBD pretty soon, and this is a very interesting paper because this is done by veterinarians in Wyoming, I think, where they have one of these centers where they do a lot of studies. And what they did, they took ewes, which is goats, and they divided in two groups. Some of them received a diet to make them fat, and some regular diet. And then they delivered the babies, the baby goats, and then they followed them up. And the baby goats, for mother, they were obese, had not only inflammation in the gut, but also fibrosis. So that means there was intrauterine conditioning towards a pro-inflammatory state in the intestine of these baby goats. So it's quite possible that when we see a child with inflammatory bowel disease, maybe what happened, which is bad, is not just the milk or the antibiotics only life, but the behavior of the mother during pregnancy. So we can see that these influences are really very subtle and pervasive. And the outcome of what we clearly found, fibrotic terminal ileum or perforated large bowel, maybe starts many, many years before. I'm personally convinced that IBD at the time of diagnosis, even in a child, is a chronic disease, probably a condition early in life or even before that. And again, this brings up the issue of personal behavior and what may affect the progeny. I now take advantage of the fact that we talk about fat and show this cartoon from an editorial in Nature Immunology showing that now fat is really a very active, bioactive organ. And when you have obesity, you have dramatic changes in the immune composition of the organs affected by obesity. There's a loss of Th2 cells, which tend to be immunosuppressors. There's a loss of regulatory cells. And there's an increase in CD8 effector T cells. So if you think about this concept, and about only a few years ago, the idea that fat was modulating the immune response, it was totally unknown. So we keep adding non-classical immune or inflammatory responses elements to the modulation of the overall immune homeostasis. And when we apply this concept to inflammatory bowel disease, when I started to get involved in IBD research, everybody was doing B cells because antibodies were the only thing that people could measure. Then people started to focus on T cells, and the IBD was a T cell mediated disease, and I also believe in that. But then if you look at the fact that most of the cells that act on it are actually not this type. These are the only two types of cells that are of the adaptive immune system, the late response. What the immune system is made is largely by innate immune responses, which are nonspecific. And all the other cells in the gut, the epithelial cells, the endothelial cell, mesenchymal cell, adipocyte, platelet, and so on, they're all innate immune cells. So we have a preponderant composition of response, which is innate immunity, immediate response, to which we failed to balance properly, and only later the innate immune response, the adaptive immune response comes in. And this, I think, conceptually is a very different view that we had until a few years ago. So if you're going to study IBD, unfortunately, we still have to study T and B cells, but essentially all the other cells that make up the bowel wall. All these cells, for instance, have toll-like receptors, all of them, which means that all of them are modulated by the presence of bacteria, the quantity of bacteria or viruses or fungi, and the quality of them. So the picture of what modulates the immune response in IBD has become much more complex.